Previous class we have taken up the assignment of TPS, think pressure activity, the fire demand. We will continue that the next one. Actually, fire demand is a part of water demands. Water demand are basically the requirements of water for various purposes. This slide presents you the basic uses of water. Domestic, we know that drinking, cooking, bathing, washing, flushing of toilets, gardening and air conditioning. These are the purposes for which we require the water. Then comes the institution requirement. Institution requirement we cover mostly schools, hospitals, hotels, hostels, office, cinema and concert halls. And then comes the industrial. Actually, industrial is not a part of the domestic city water supply system. There are specific requirements of the industry. Public usage, basically the water required for the public utilities like the public garden, public toilets, road washing, etc. The fire demand that we have taken as a prerequisite. There is another part of the water demand. Wastage and losses, they are 15 to 20% out of the total water requirements. When you look at the institution requirement, 45 LPCD is meant for office and school. Hotel 180 LPCD. Cinema halls 15 per seat. Restaurant 70 liter per seat. Airport bus station 70 liter per capita. Hostels are as same as the domestic requirement. The per capita requirement for hospitals depends on the number of beds in hospital, greater than 100, less than 100. The most important part of the water demand is the domestic requirement. So if you look at this particular table, the water demand is related to the population. Less than 20,000 population, the supplies to the standpost public community tab, you have 40 LPCD. And the house service connection 70 to 100 LPCD is a assigned value. 20,000 to 1 lakh, it is 100 to 150 LPCD. More than 1 lakh, 150 to 200. These are the values that are derived from the manual on water supply and treatment published by Government of India, CPHU. Industrial requirements basically depend on the per unit production. For example, 1 kiloliter or 1 meter cube of a distillation and product requires 120 to 170 kiloliters of water. Per ton of sugar produced consumes about 1 to 2 kiloliters of water. Per ton of paper produced requires 200 to 400 kiloliters. Similarly, per 100 kg of textile linen produced requires 4 to 14 kiloliters of water. They are industry specific requirements. Normally, this supplies should be covered by the individual industries, not a part of the public water supply system. This is what has been discussed previously. TPS activity, we were assigned with estimating the most appropriate value of fire demand. They were estimated by the population based empirical formula, manual based empirical formula, and area based empirical formula. And using your thinking on your own, pairing with others, and sharing the common use, you have arrived at an appropriate value of fire demand for 1 lakh population. And the fluctuation of water demand is very important in the design of water supply system. Fluctuation is basically the variation of water usage with respect to time. Fluctuations can be seasonal, daily, hourly, and water demand is basically affected by these factors: size, characteristic, climate, metering, system of supply, pressure, quality and cost. Because of these factors, we will have different fluctuations. And the typical hourly fluctuations reported by the manual are 3 for less than 50,000 and 2 for greater than 2 lakhs. So if you look at this variation, larger is the population, lesser is the peak factor. It means that large population activities are varied. There is a dampening of the peak flow, and hence the peak factor goes on decreasing as you have an increase in the population. And the hourly fluctuations are more important in designing the distribution pipes, service reservoirs, and the pumps. The most important part of the water demand fluctuation is for the design of water distribution system. And a coincident draft is a combination of maximum daily with fire demand is considered to be a coincident draft. There is another possible value, maximum hourly demand. When you estimate the design flow for the water distribution system, you will have higher of these two combinations, maximum hourly or maximum daily plus the fire demand. And here comes use of the fire demand in the system. Basically, when you estimate the water requirement for a town, the population forecast is very much important, because the estimated requirement is not for the present need, it is a need for the future. When you look at need for the future, the design period is very much important. The basic definition of design period is the useful life of a component. These are the four factors that affect the design period. More is lesser design period. Less difficulty, more difficulty, no design period. Funds are more design period. Rate of interest is less, higher design period. The growth of population. So depending on these factors, the different components in the water supply system have got different design periods. Normally, the water supply systems are designed for a design period between 30 to 50 years. And for this period, the future population has to be estimated. And these are the different methods of population forecast: arithmetical increase, geometrical increase, incremental increase, decreasing rate of increase, simple growth, comparative, zoning, master plan, and resisting. And the incremental increase method is the one that predicts the population in a better way. That is between arithmetical increase and geometric increase. To summarize, for estimating the total water demand for a city, we need to know the per capita water supply, we need to know the design period, we need to know the population forecast. Estimated future population multiplied by per capita supply, that will give the average water requirement for that particular city. And depending on the component for which the design is to be done, you have to select the appropriate peak factor and end up in a estimated value of a